Hello, everyone, and welcome on, don't know what time zone you're in, but for us it's Saturday morning, so welcome to Saturday morning. We are going to be doing, hello, we're going to be doing a hangout on all about Cosmo Quest's professional development for TerraLuna, which is a unit that we've created using Cosmo Quest and using citizen science in the classroom and using lunar science in your classroom. So I am Nicole Gallucci. I don't have lower third working today. Sorry about that. I am a postdoc with Cosmo Quest, and I'm joined by Georgia Bracy, Ellen Riley, and Cathy Costello. Each of you, if you would like to say hello and a quick blurb about yourself.
Sure. I'll go first because I'm closest to the screen. Hi, I'm Georgia Bracy. My two colleagues here with me, we're going to be sort of in and out of the screen as we share one computer here. I'm a former 5th grade teacher, did a lot of elementary education a while ago and loved teaching science. I am now a research associate at the STEM Center in Southern Illinois University at Edwardsville. And I now work with Cosmo Quest doing the formal education side of things, so helping to work up some nice units like this so that you can bring citizen science and all of the Cosmo Quest good stuff into the classroom with your students. So then I will let Cathy Costello maybe go next. Come on up.
As close as I can get, I feel like I should be lunging toward the screen. I'm Cathy Costello, and I have a couple of decades of experience teaching middle-level science. Did everything from astronomy through zoology and had a great time doing it. I am now an educational consultant, I think, is my title for Cosmo Quest, and helping to put together units and professional development for teachers.
Okay.
Ellen,
there you go.
Yes, I am Ellen Riley. I have about over 25 years experience teaching middle school and high school science, primarily middle school, and I am retired and working as an educational consultant on this unit. I have taught school in Turkey and Thailand and the United States.
Awesome. Just some great experience. Okay.
Yeah, I'm feeling some super imposter syndrome here. With all these amazing teachers, and I'm like, hi, I'm a postdoc. Yeah. So I'd like to repeat again, if you'd like to comment or ask questions at any time during this hangout, there are a couple different ways you can do that. You can leave a comment on the event page itself if you're watching there, assuming I got the video working there. I'm not sure if I did, but you can leave a comment on the event page. So hello, Germany. Glad it's a nice normal time for you. You can leave a comment on the Google Plus page, where the Cosmo Quest page where this is being broadcast, or any of the shared broadcast sites on Google Plus. We'll be tracking comments there. You can leave a comment on YouTube if you're watching the embedded stream, or if you're watching straight on the YouTube page, leave us a comment. Or if you would like to use Twitter, use the hashtag CosmoQuest, and I'll be tracking that as well. So be sure to ask any questions of us while we're talking about this unit, and give us some feedback while we go. Actually, so first thing we'll show you is how to get the Cosmo Quest unit that we're talking about. This is all as a PDF, and I will screen share what I'm looking at here. I hope that looks good. Okay, so if you go to our webpage, cosmoquest.org, up at the top, we have our main menu with all these fabulous things up here. And if you go to Cosmo Academy, you will see several things. Oops, don't actually click it. If you just hover over Cosmo Academy, you'll see several different topics. We have classes for our online classes, Educator Zone, which we'll be talking about today, and Science on the Half-Sphere, which is Planetarium. In this future site upgrades, we're probably going to move this Educator Zone tab out to the main menu, so it'll be more obvious. You just click Educators. So if you go to Educator Zone, we have some resources for you, both internal and external, places you can go for different teaching resources. And we're talking about this top section here, TerraLuna. So this is classroom lessons for middle school, and there's a little blurb about it, and there's a link that says get the PDF here. I realize I should probably link more text than just the word here, but we're go with that for now. And that is where all of these lesson plans we're talking about are stored. You can download the PDF. It's free. You get all this information, and we're going to talk about how to actually use that here today. And screen share off.
Okay.
Georgia, do you have any other intro?
Just one thing to add, I put a little survey at the end of the TerraLuna unit, so you'll see that at the end of the PDF file. Just some nice questions for you to give us some feedback, because really this is still in the piloting stage in a way. We are looking to continue to make this better and better, and if you guys can try all of it or even just some of it and give us some feedback, and we'll talk more about how to do that in particular at the end of the broadcast here, but that's really what we would like you to do after watching this and downloading the unit. So be thinking about how you might be able to use some of it in your classroom, and then give us some feedback. Okay.
Feedback is good.
We want feedback. Yeah. So the next thing I think we'll move to is Cathy is going to kind of do a little overview.
The purpose of why we did TerraLuna, the excitement of students actually doing research is what drives the TerraLuna unit, because they get to participate in the online activities of actually marking craters on the moon. And students are highly motivated by such things, and that's what's going to be the basis for the unit. The working of online with the MoonMappers section of Cosmo Quest is an integral part of the unit that we designed. This is a comparative geology unit that compares the geology of the Earth to the geology of the Moon. That way we're hitting more science standards, both in Earth science and in space science, which keeps all of our teachers and principals happy everywhere. We've done quite a bit of looking through several sets of standards, with standards in the United States nationally being what they are right now. We're just on the brink of getting those next generation science standards, and we're excited about that. But in the meantime, while we're waiting for those to solidify, we did make sure that we pointed out all the links to the 2061 standards, as well as the National Science Education Standards. We realized the international community looks to those as well, so we made sure that each of the activities was linked to those standards. We did make an attempt, though, to put the next generation science standards in there, because we thought that would be helpful once those are totally public and finished. Those will be the basis for the units and all the rest of the Cosmo Quest units. So there is a little bit on there when it comes to the overarching and cross-cutting concepts that are featured in the next generation science standards. So as we go through, if you find another standard that we missed, oh, please share it with us. We think we got them all, but there's a heck of a lot of them out there right now. I wanted to just go over a brief overview of the unit and explain what happens in each day of the unit. We're hoping that you'll join us again next week when we go a little bit more in depth into some of these plans. So this is just a teaser for what's to come. In the 15-day unit, for the first day, we take the introduction of why the moon. Why do we even study the moon? And in this case, we're using it to compare what we can measure on the moon with what's happened on Earth. And you can see a good comparison, for example, of cratering. The activity that we're going to do that day is to compare Earth and lunar features, and Ellen is going to give you an example of that in just a little while here. On the second day, we talk about the origins of the moon and the Earth, since there's a coevolution going on there. And we are going to be using, for that day, the reaping rocks activity. Instead of reinventing the wheel, we used a lot of the different activities that are available at nasa.gov. And one of the ones that we liked the best for that day was reaping rocks, because it takes a look at the rocks that are available on the Earth. On the third day, we talk about differentiation, a geologic feature of both surfaces, both planets. And we use that differentiation activity that's also online. When you go through the lesson plans, you'll see a lot of links to a lot of places that we pulled off different lesson plans. and that's one of them. And we do begin that day, the second day on differentiation, with a density demonstration, a simple alcohol, water, and oil demonstration to see how those different densities layer out when they're together in a solution. On the fourth day, we turn to volcanism, lava flows, and Maria. And there are two really cool activities that really let the kids get up to their elbows in fun, gunky stuff on that day. There's either the lava layering experiment or the clay lava flows, both of which, well, you're going to want a lot of plastic wrap on the floor for some of those. But they are very good activities to demonstrate what is happening with lava as it moves, and allows them the opportunity to use inquiry to take actual measurements. Every one of these, we did our best to choose those activities that pull inquiry to the forefront and get the kids involved in conversations where they're discussing and using science terminology in order to explain what they're seeing. On day 5, we talk about craters and boulders. And again, a couple of very neat NASA activities, impact craters and making a crater. We're also going to be demonstrating that one for you today. On day 6, we'll talk about the highlands and the formation of mountains on both of the bodies, both the moon and on the Earth. And that day we'll be looking at a mapping activity where we're having the students look at a section of the moon and mapping all of the structures that they've been talking about in the first 5 days. On day 7, we talk about the differences in regolith on Earth and on the moon and how those are formed. And the activities there, there's an option of either regolith formation or the making regolith. They're similar, but they use different substrates and different materials that you'll have around. I would like to point out that we did try to pick activities that would have materials that were readily available so that we're not making huge purchases from some of the more expensive equipment from the companies that make those things. We tried to pick things you'd find in your kitchen to make it easier on all of us. Then when we move to days 8 and 9, on those 2 days the students spend a lot of time at the MoonMappers site doing the actual explorations using the information from the Lunar Reconnaissance orbiter. They're taking actual photographs that have been sent to Earth by that orbiter, and by looking at those maps and gauging what craters they need to mark, they find some pretty interesting things and make some awesome discoveries. In some of those pictures, they may find the remnants of different space probes, or even the Apollo equipment that was left behind. Those show up in some of the photos. Also some very interesting craters. The fresh white craters are definitely something that are pretty to look at and fun to interpret as well. Then on days 10 and 11, we talk about anomalies. Discrepant events are really good motivators for students. When things don't happen just the way you expect them to, that really perks their interest, and they'd like to know exactly why it isn't the way they thought it was supposed to be. So on that day, we start with a discrepant event, and we give you a list of several events that you might want to choose, several activities that you might want to choose. And then we also give them a list of moon anomalies, things that we might still be trying to figure out, and allow the students an opportunity to research some information that might give them clues as to the meaning of those anomalies. And then the teams present their hypotheses to each other through the course of the class. On day 12, we focus on exploration of the moon, and this is the day where they look at the Apollo landing sites, look at some of the video from Apollo landings that's readily available online, and give themselves a day to imagine what it would be like to be an astronaut exploring the moon. Then on day 13, we're going to go back to mapping more of the moon. Oh, and in here we also have, I'm sorry, I forgot, on days 8 and 9, we have Nicole's very excellent mapping activity, which has them actually figure out what the relative age of some of the craters and some of the sections of the moon are based on the crater data that they collected on days 8 and 9. On day 14 and 15 is where we turn our attention to evaluation. We allowed a day for review, and the 15th day we do have tests that are embedded in the lesson plans. You'll find there are quizzes, there's a pre-test, there's a post-test. We included the keys for those so that we can we don't have to go scrambling to find the answers elsewhere, as we sometimes do as teachers. In each of the days, we also supplied information about things that you can do beyond the science classroom. So we have possible extracurricular links, links to language arts, links to math, links to the arts, social studies, to give the students an opportunity to see how science is related to all of the other content areas. We also give you some extension activities for each day. Those are nice because sometimes they could be the alternate activity that you do in class that day, or if you have extra time, you can include those. Things like looking at Apollo samples and debating the possible outcomes of a meteorite hitting the Earth as compared to hitting the moon, and letting them have a little bit of creative license with coming up with what might happen given the information that they've been taught. You'll notice too that all of the lesson plans are set up on the 5E format, which encourages inquiry. We go through the engage, the explore, the explain, the evaluate, and the elaborate in our lesson plans. We do know that we packed a lot into a day, and we don't expect you to get through all of that in one class period, but what we were trying to do by doing that is giving you plenty of options so you can choose what fits best for your students in your classroom at that particular time of the year when you're doing the unit.
Cool. Well, we have a question really quick on this from James asking, what grade levels do the materials include, and do you feel that the drive to teach the test might blunt the use of the materials for teachers?
It depends on, let me answer the first question first. Okay. The materials are geared towards the upper middle level, which means grades 7 and 8. So that would be students aged 11 through 13.
Possibly 6.
Possibly 6. And we all know that you can do adaptations to go down or up. That's why we gave you all of the different resources that you could possibly use. Now, as far as teaching for the test,
do you mean teaching to the standards, perhaps?
Teaching to the I'm not sure.
I think that might be the general feel of it, is teaching to standardized testing.
Which is why we have, of course, the standards are different, can be different in different states, and we have included the 2061 standards, the NSES standards, and we have aligned it to the last draft that we saw of the next generation science standards. So we feel that if you taught this unit, you would be teaching to the standards, particularly in the areas of geology, which is, comparing the geology of the Earth to the geology of the Moon. So I think that the standards would be included. I mean, you would be teaching to the standards by teaching this unit. Does that help?
I think so, yeah. Yeah, so you can still get that obligation in teaching to the standards.
I'm very sensitive to I mean, I haven't been out of the classroom that long, and I'm extremely sensitive to teaching to the standards and yet doing exciting things and inquiry activities.
Right, and I think through this unit and linking it to the different content areas, what we're trying to do is prove to anyone who needs it proved to them that there is plenty of time for science in today's classrooms, regardless of the current push to standards-based education is always a good idea, But as the stakes go up, we have to be really attuned to where those standards are falling in our lesson plans. And I think giving opportunities to link it with other things that might be hit a little bit more, like mathematics, for example, is heavily tested in the United States. So giving them an opportunity to use mathematics to learn about the moon gives us yet another way to sneak science into our classrooms.
Excellent, excellent. And yeah, he points out his nephew is just getting to grade school and has a love of space, and he doesn't want to lose that. He doesn't want him to lose that love of space going through the educational system. And I think we're trying to combine all those things.
He's right. He's talking right up my alley there, because
Yes,
I am science yamma in my family, and I do experiments with my granddaughter, my 3.5-year-old granddaughter, who is terribly interested in space. It's a natural interest, and I want to continue it. And she actually has done some of these activities. Just recently, the regolith activity, because I want to prove if a 3-year-old can do this, then certainly a 7th grader can do this. So I have pictures of her that I'm going to put online.
And that's the whole basis for the inquiry approach. If we use the 5E format, if we make sure that the activity before the content, if we make sure that the students are inquiring on some basis before we give them the content, then we're hoping to nurture that curiosity and keep their interest alive.
Cool. Okay, so we're going to head up to the next activity. Ellen.
Which is day 1, essentially. That every unit has an introduction, and our introduction on day 1, why the moon? And what a good way to work with to engage the students, we felt, was to put them in groups. I would put them in groups, although you could do this individually, and hand them a set of pictures, 10 black and white pictures. 5 are the moon and 5 are the earth, and they have to decide what is what and give reasons. Because after all, we are going to be comparing the surface of the earth with the surface of the moon. So let's start out by looking at some of these pictures. I have one that I'm going to hold up. And I wonder if you can see it. Can we see it real close? Can you close it to get? And
You can look for the digital version too.
You can look for the digital version. All of you who are out there, you know, you can try to make your own decision. Is that Earth or Moon? Earth, Moon. Why? You know, what do you see? Is it similar to something? The kids might say it's similar to something that they have seen published in a magazine. Somebody might be looking for evidence of life. There might be one who says, wait a minute, is there evidence of life? Is there something in there that would give a clue? And so I will give you the answer. And it's actually a volcano in Colombia. And so, frankly, sometimes if I don't have them labeled, I have to think really hard before I get confused. Then you might hand them, I have another one that actually has been gnawed a little bit at the corner because my cat was eating it. Sorry about that.
Awesome.
You know, science isn't perfect. What can I say? So it was on the desk and the cat was on it. So I would have them say, well, what do you think? Have them classify this. Have them discuss it among themselves. And it's been my experience that middle school students can be rather opinionated. Imagine that. And so they might argue back and forth. Someone might say, well, that looks like a stream to me. That looks like it has to be the earth. That's a stream. And someone else would say, well, I don't know. I don't think so. And actually that is a lunar rill. That is from the surface of the moon. So it's not necessarily easy to figure these out. I'll go through just a couple more for you. Here's, I think I like this one better. I'm going to hold this one up, Georgia.
Yeah, I can't find the black and white one, so
That's okay.
Go.
This is really cool. This one, and this is kids might give various reasons. Thinking about this, well, I'm not sure. And the reason it has to be black and white is that occasionally there might be too many clues, like there might be evidence of oxidation, or there might be a little bit of foliage in the corner of the picture or something that'll give it away, although that wouldn't be necessarily a bad thing because it would be a clue that a student would use. And that is actually the Badlands in South Dakota. So that is the Earth. And I will show this one, this next one. And this one looks very barren. Looks kind of a little bit like regolith on the bottom. You know, it's very powdery and so on. But I'm hoping a student would say, it looks kind of like there's been some wind too that has pushed this Earth around, and of course the Earth has an atmosphere and has wind, and it is a desert, actually, a desert area on the Earth. Yeah, another one should be here. You see this one, and how hopefully students would look carefully at this one, look for some clues. Does that look like the Earth or the Moon? Give us some reasons. And that is actually a lunar surface. That is a lunar surface. This was another good one. Yes, and I like this one because it has a volcano look to it. And so they would be possibly a little confused. The idea is to show them the similarities, and it is actually a lunar volcano, so that we might have students put that in the Earth category, or somehow hopefully in the Moon category. But by the end of the TerraLuna unit, they would probably be able to do this better than I can. So, and we'll do just one more here, so because I think you have the idea. And this is a lunar surface. And students, yes, it's craters, and definitely activity, it definitely shows cratering, and I would hope that the students, from just general knowledge by middle school, would be able to say that looks like craters to me. And so they would explore that. They would actually do something on the first day. They would start their moon journals, where they would journal about what their activity was and what they've done and why they classified these pictures. Each group would present the pictures and give the reasons for putting what pictures would either the Earth group or the Moon group. And so basically the concept of that day would be features of the Moon have their equivalents to features on the Earth. Okay, Cathy.
Alrighty. Now, in keeping with our idea of using things that are readily available, we have plate tectonics in a box. And this is just a plain shoebox, okay? Nothing inside, it's empty. And there is a hole cut on one side of the box right here. And there is a slit down the middle here. And all you need is a marker and 2 pieces of paper, and I'm going to get my pieces of paper lined up. Oops. Excuse me, I have to remove my continental crust.
That can be a problem.
That is a problem. Continental crust. I mean, what do you do with it, really? Okay.
There you go.
And we get these in. And some of you are already thinking, oh, I know what this is going to look like. Okay, and by moving, okay, this represents, of course, an oceanic like the mid-Atlantic rift, okay, where we are building things there. And this represents the continental crust, this part taped to the paper. And we've got a little bit of seafloor spreading going on here. If you push the paper up from underneath, you can see that the pieces of paper move away from each other. If you want, and that can be the, oh, wouldn't you know, now I can't remember the word. If you pull it together, you've got convergent plates. If you lift the paper up again, you've got diverging plates, which is the word I was looking for. And then, hang on, I'm going to do one thing and then I'm going to flip it. And if you use your marker, before you move the paper out, if you take and color in a nice stripe here on both pieces of paper, okay, and then do your diverging plates to get some seafloor spreading, and then color periodically, you know, stop and make another mark, you will get a nice indication of the magnetic anomalies that scientists use to prove that the seafloor was spreading equally. And so you have this, you can point out to the students that the distance between these stripes, well, should be more or less even. They're a little bit crooked on this one, but they should be symmetrical. So that the students can see that those pieces of the plate were formed at the same time, and those pieces of the plate moved away from each other as the seafloor continued to spread. And that's what gives us a great clue as to continental drift. You can even show a little continental drift here. If you want to get into a subduction zone and put in, I'm going to put in another piece of continental crust here. Okay, and now as I pull these two together, you can see that eventually these two pieces of continental crust are going to approach each other. Okay, they didn't do it evenly, and bingo, there's the Himalayas. Okay, so where two pieces of the crust are banging into each other. And then you can use this several different ways in order to teach the students the basics of continental drift. And again, if you do use the markings of the anomalies, you again have something that they can measure on which to base their inquiry, so they can actually measure the distance between the different marks that they made to represent those anomalies.
And that actually is, that's an engage activity for day 6. And it would be, day 6 is the Highlands. So that's a wonderful engage activity for day 6.
Right. And we would be, and during the course of that day, we are comparing how the highlands formed on the moon compared to how mountains can be formed on planet Earth. So of course, you know that there's not that plate tectonic activity going on the moon now, but you can use it to point out to the students the differences between the two bodies and how their highlands formed. Okay. Okay.
Awesome. I love that activity because, like you said, it's like simple home materials you have at home, and so it's not super expensive to put together. And I love those types of activities. Having worked on, you know, shoestring budgets for after-school programs,
it's fun to make it done with 2 desks pushed together, and instead of a box, you just pull it up out of the crack of the desk. So that's it. We can get it even more
scale.
Awesome, awesome. Okay, so I'm going to give you guys a brief tour of the MoonMappers site. Now I'm sure you are all, you know, excellent, wonderful MoonMappers at this point, but in case if you are unfamiliar with it, this is, I'm not sure what day of the lessons goes into this, but this is something you could do with your students as well.
8 and 9.
Right. It starts on day 8 and 9, and then they really do it on their own on day 13. That's when we cut them loose and see how many craters they can identify in an hour.
Awesome. So you go back to the Cosmo Quest site. You go up to Do Science, and that's where all of our citizen science projects are. We have, right now, we have MoonMappers and VestaMappers that are live. Ice Investigators is here, but if you've been hanging around with us for a few months, you know that you guys were so excited about Ice Investigators that you did all the images, and we're still waiting on more from the telescope. So good job on that. We'll have more coming soon, hopefully. But this particular activity talks about MoonMappers. And so MoonMappers has been around for some time using data from the Lunar Reconnaissance Orbiter, very high-resolution images of the moon's surface. And we need your help to actually map it. So you can go to the Simply Craters activity. That's the most basic activity. And when you first log in or sign in, it will present you with a tutorial that will take you through these steps. But because I've already done the tutorial, it will skip that. And I can show you a demo version right here. So this is our high-resolution image of some tiny, tiny sliver of the moon. And there's an indicator telling you about where the sun is from, the sunlight is coming from in this image to give you an idea of how, why the shadows look the way they do. And what we want you to do is go through and mark the craters. So you use the Mark Craters tool and go over to a crater. Now you want to get them larger than this little green circle here if you can see it. So don't worry about all the tiny little craters, but get your students to pick out as many craters as you can. You do that by clicking on the center of the crater and dragging the circle out to the rim. And so you want to get, there aren't too many really sharp craters in this image, but you want to get it about to the size of the rim and mark that whole crater. Could be some fainter ones here, like this. You can tell there's a little bit of a shadow of an eroded crater, and so I might mark that one as well. With the more eroded craters, you have a little bit of leeway in terms of where the rim is, but do your best guess. We always have several people look at every image and mark every image so that you get kind of an average from several users as to how big the craters are. And when you think you've gotten all the craters in the image, if there's anything else that's odd, you can always click on, say, a linear feature, like those rills. Anything that's odd or just a bad image that needs to be taken out, you can use the Mark Feature tool, and that'll tell you what that is. If you make a mistake, like, oops, I made a big circle because I clicked the mouse wrong, you can delete marking and delete that circle. So pretty self-explanatory. You have some examples over on the left of different types of craters. You don't want the really tiny ones again. You do want the large ones even if they're fairly eroded. And then you hit done working and it submits and you get a new image. And this is where it gets super highly addictive because you say, okay, just one more, and then you see the next image and it's really interesting and you want to do it. So that we do keep you engaged in that way. If you go back,
before
yeah?
you go back.
Yeah.
Or okay, go back.
Oh, sorry. I clicked too fast.
Oh, no. Can you go back and talk a little bit about albedo, and because that's something to look for, and that is sort of a link to what we'll talk about in our next activity a little bit too.
Okay. So
yeah, I don't know. That's not too bad a picture. Kind of depends on what picture you get.
So you're saying like light or dark features?
Yep, exactly. Just
okay.
Especially,
yeah. Let's
point out some lighter ones if you can.
So yeah, so when you click Mark Feature, and that'll tell you that there's you can choose from all the odd features that are not necessarily craters. So a light albedo feature, so some light material on the surface. You might want to mark that. So you choose that from the menu, and that looks like a light patch, kind of odd light patch, and so you want to mark that. I would also mark if there's an odd, I'm not sure what odd albedo feature is, if it's like dark and light altogether. Odd shape feature, there's definitely some linear features in this, so I would click that as well. So now the dark and light features are not the same as the crater shadow. You want to make sure you don't mark that as a dark feature. That's a crater shadow, and you would mark that crater all on its own. And same over here. So does that cover what you?
Yeah. Yes.
Okay. Cool. Cool.
Point that out in an actual image because we'll talk a little bit about it in a minute.
Right.
Thanks. Yes.
Right. And if you're really lucky, you might actually we've got the Apollo 15 landing site in this image set as well. So you may actually see spacecraft in your image, which is pretty cool. So let's go back to the main MoonMappers page, and I'm going to show you the second task, which is man versus machine, and this gives you a sense of why we ask people to help us mark these craters, and we don't rely solely on computer algorithms. And so this is an image that's already been marked by a computer algorithm, and it says, I've gotten all the craters. And you look at this image, and I would call this a crater as well. And so it misses some of the more complex or eroded features. And so this is where you come in and actually correct by adding in the craters that it might have missed, or moving around, deleting or resizing any of the crater markings that the machine might have missed. And it's probably also missing some of the weird features. So our pattern matching human brains are doing better than this algorithm at finding, say, a light albedo feature, because these craters have brought up some interesting light material that I would mark as well. So that's the second MoonMappers task that you can have your students do. And click done working. And just to give you a sense of how far we've gotten with MoonMappers since launch, we asked you guys to map 1 million craters, and we are almost at 1 million craters now. And so we're getting our first science results, and that is they're working on the publication now for scientific journals, so we'll be reporting on that soon. With both MoonMappers and Asteroid Mappers combined, we've gotten up to 1 million craters, but just on the moon, we're almost at 1 million craters, and we'll celebrate that, and it'll be awesome. If you want to track your students' progress, you can ask them to show their My Stats, and that slow load. That gives you an idea of how many craters they've actually marked. I've got, say, 114 markings that have been confirmed in all of my crater marking experience. So your students can also report back to you with how they've done. Yep.
Okay, thank you.
All right.
Very good. All right, then I think we've got one more activity, right?
Yeah.
Another fun one.
I get to do the fun one.
I know.
You're going to want to back up that computer.
Yes.
Oh no, we want it.
Here we are. I get to do the messy, fun one that students will love to do. This is impact craters. So essentially, they are going to bomb the moon with simulated meteorites. And I think every student I have ever had in 7th or 8th grade would love to do this. So first of all, obviously, you would go through pictures of craters and features of craters and talk about depth and floor and ejecta and the vocabulary that goes along with cratering. Then you would put your students in teams, and you would have them prepare the surface of the moon. Again, common objects that you have around the house. So we're going to use flour.
We should show, this is one of those big aluminum roasting pans. You might want to get something with higher walls on the box, because as you see as we go through this activity, the ejecta has a tendency to go everywhere.
It does.
And then we have another pan inside a black plastic.
So the first thing you do is you have them prepare the surface by pouring flour in the surface of in the one pan that's inside the big pan. Maybe 2 to 3 centimeters. I think I put a lot more than that. Oh, that'll be fun. We'll make nice deep craters. Okay.
Okay.
That's the surface. We are, you see? So then we are going to put some kind of contrasting color on top. In this particular case, it is cocoa. You also could use any of those drink mixes that are any color, cherry or lime or whatever, and you can get in huge cans, and they're very inexpensive. So we will kind of sprinkle this on, and you can do this with just sprinkling it like I am, or you could do it with a sieve. Just make it better. What do you think, ladies? Here we go. This is nice. Good. Looking good here. Okay, so now they've prepared the surface, and we need to have meteorites, simulated meteorites. Come in all sizes. If you can see this surface.
Okay.
Yes. Nom, nom,
nom.
It smells good.
It smells wonderful. I have tiny ones. This is a little marble. I have huge ones, golf ball. And I have a data sheet. Oh, kids just love the data sheet. Every time they would see a data sheet, they'd say, oh no, I see a data sheet. I'm seeing a graph in my future, Mrs. Riley. And I said, oh, imagine that, yes. So, so there is a data sheet. Again, teaching to the standards. You're bringing math in. You're having them collect data and so on and analyze data. And you would have them use different size meteorites, simulated meteorites, and different heights. So we will start with the small one. And I can estimate, I don't know, about 30 centimeters, and you can have them drop it in there.
Nice ejecta.
Nice ejecta. And they would then take the meteorite out, and they would actually measure the crater depth, the diameter of the crater, and the number of rays that are coming out from after the projectile has gone in there. They count the rays, measure them, and average them. Averaging. Okay, there you go.
Very good.
We can then take this higher and let's go way higher, and I would drop it higher, and then they would compare the depth of that crater, the diameter of that crater, and so on. And then, of course, what they've been waiting for.
Backing up.
My colleagues are all backing up, and this is fun. Look at how much deeper that one is. Isn't that wonderful? Perfect. Yes.
There we go.
And we'll start with my huge meteorite, which is going to go down in there.
That was great.
You couldn't even hear it.
I heard that down the hall.
Lab would be
And
really.
you can do relative age with that
This is,
because
you
the
wanna
big
show-
meteor.
Can you pull it back a little bit more? Yeah, and show the, yeah.
See that.
and
But
it's
now it's
covered
pulled
up.
out.
It's covered up the older craters.
It's covered the
with
older
ejecta
craters.
from the
So
first
yes,
one.
imagine,
Pretty cool.
and yes, it is cool, and they would really love that, you know. And then of course you can change the
Oh,
the
go
altitude.
ahead.
Go ahead.
You want to.
I
know you
do. I read someplace that someone did this from a second story. That
Oh my
kids,
gosh.
which would probably be, you have to be a good aim, but you know, it would be really fun. Okay. Whoa!
And it bounced.
It bounced.
We can't see it. We can't see it.
can't see
Show
it.
it back. Yeah.
It hit up here and it
It
bounced down
hit
there.
here, and it bounced to here. They would love it.
Yeah.
It'd be wonderful.
Lovely data set.
And lots of
Uh,
cool data.
talk about the difference between the colors and why we have two different colors, and connect that with what Nicole was just showing.
Do you want to go ahead and
I
do
can.
that?
Well, all right.
Just
And it also-
Whoever.
And it also
jump in.
talks
That's okay.
about the regolith formation and the way that the material that was underneath gets brought up to the top and gets thrown out and rays as the ejecta,
Yes.
the rays of ejecta as an object hits.
Mhm.
And I can imagine there would have been some bouncing perhaps on the moon, which would give you interesting data when you're looking at your the craters when you're doing your mapping. So
Yes, so we use two different colors, and the idea is that the fresher lunar material is a lighter color. So that's one reason why scientists are really interested when you're doing MoonMappers, and they would like you to mark on your image a lighter albedo feature that you see, because that means that that is a relatively new crater. Something, you know, the moon's surface is not just the same, and how we've always, at least I've been brought up to think, you know, nothing ever happens there. There's there's no atmosphere. It's just, it's the way it is. Astronauts went up there and they walked around and their footprints are still there. I mean, because nothing ever changes. But actually there is a lot of interesting things going on the moon. It still gets hit by these micrometeoroids. So when you see that brighter material, you know, that's a relatively fresh crater. And this activity actually demonstrates that very nicely. So not only do you get to see, you know, the material underneath that is revealed by the impact, but the crater rays that are going out, they're also that fresher, brighter, lighter albedo material. So that's something that's very nicely demonstrated by this activity. And the bouncing, you know, there was just, I can't remember now, somebody just posted, it was probably Phil Plate, actually, just posted a picture of the moon, and it showed a boulder that had rolled down and left a trail. I mean, things are still happening on the moon. Don't think that it's just an old, boring, nothing ever happens place. So this is an activity that you can really talk a lot about that too.
and it does tie in nicely to the crater activity that Nicole will be presenting next week, won't you?
Yes. Yes. Yes.
Want
It
to
will.
see the exciting what this leads to, where the students actually do some aging of craters on the moon. This ties in nicely because the most recent crater building episode covers up some of the older crater episodes, so you can tell which one is relatively older than the other. So they do nest and link with each other.
Wonderful.
Yeah. We have a comment from Christopher who points out that a fish tank makes it a bit easier for cleanup.
Perfect.
which is excellent.
Wish you would have told us that like 15 minutes ago.
And something that I think we have across the hall in the STEM Center, using magnetic balls for the meteors is good for retrievals. But if you have a large, if you're losing things in that fish tank, if you can use something magnetic to retrieve them. I think we have some across the hall in the STEM Center that I use occasionally. And recording their impacts with a webcam is fun as well, he says. I can imagine slowing that video down.
Wonderful idea.
Very good. Thank you.
Yeah. And this is it's a great activity because they get a visceral feel for, they're not just these, these pictures of circles that you're doing in MoonMappers. This actually brings it to life, and here's what's actually going on the surface.
Well, for all your tactile learners, too.
Right. And you you were saying about how things are still happening on the moon, and that's one of the current areas of research that we're using the MoonMappers data for, is seeing what has changed from since the Apollo era. And messy science equals attention getting science. Absolutely.
Absolutely.
And if you like this, wait till you see the lava layering.
Well, yeah, lava layering.
Yeah, we have lots of questions.
Yes.
Yeah, when I did this activity in Virginia with Dark Skies Bright Kids, we would do it outside, but then the kids also discovered that when you mix water in it, makes some sort of cementy mixture. So don't let them mix water with it, because that's just bad. But yeah, it's another favorite activity for we did this activity with 3rd, 4th, and 5th graders, so that's a younger age range for that, and slightly inebriated adults also enjoy this activity as well.
Well, the first time I did this activity, I did it with mud. Because the activity was called Mud Splat Craters. And the nice thing about that is you don't get the ejecta so much because there was no color contrast in that experiment. But it is easier to measure, and you can actually let it dry and come back to it for later activities on measurement and labeling the different parts of the crater. So there's another option if you don't mind mud.
If you don't mind mud. We love mud. We love mess. If you have any questions, I think that's the last of the activities we were going to show. If you have any questions, please, this is the time to ask your questions. I'm monitoring the event page on Google+, also the Google+ post, also the YouTube page. If you leave a comment on any of those or a question, I can see them. If you are watching somewhere else and want to use Twitter, use the hashtag CosmoQuest. We are following that as well. So you can ask us any questions. We will be repeating this, so not an actual repeat, but us coming back in the office and actually doing this again live at 8 o'clock p.m. Central Time. Figure that out in your own time zone. Timeanddate.com is an excellent resource for figuring out when things are, but there's also an invite for that event for that. So we're hoping to hit teachers in as many time zones as possible by doing this again tonight. And as we've mentioned, we're going to be doing a part 2 of this next week, next Saturday. So we're going to be doing a more in-depth training session with these activities. If you are really interested in doing this in the classroom or with your after-school group or with homeschool students or anyone, you can sign up for one of these. It won't be a hangout on air, so it won't be publicly available. It'll be a private hangout. You'll actually come in the hangout with us, so you'll need webcam and headphones, and actually do the activities with us. We'll be doing it more in depth, and that's when we can do the Crater Age activity, since that's a little bit more involved. We're going to do it there. I've set up 2 Eventbrite pages, so since it's a private hangout, we're limiting it to 8 people for each one, and I will go ahead and post those links as well. It's TerraLuna2.eventbrite.com or TerraLuna2late at eventbrite.com. That's where you can sign up. I'll be posting those right now on Google+. That's where you can sign up for next week's part 2, where we go in depth with some of the activities and lessons, and you can actually chat with us face to face and do the activities on your own at home. So it is free, of course. It's been set up on Eventbrite to be free. So if it for some reason isn't free, then yell at me, email me, and I will fix that. So there's 8 spots for 2 sessions for next week, and you can come and do these activities more in depth with us. We have
supplies too, won't they?
Yeah, so you'll need your own supplies. So you'll have to collect your own flour and cocoa powder. Once you sign up, we'll follow up with an email on what supplies you'll need in order to do the activities, and then we can give you some feedback on that. So that'll be an actual real interactive session next week. There's a question from YouTube. What if any U.S. Department of Education standards exist for designers of online activities? I don't think there are any, but I don't know if either of you know that.
For online activities?
Yeah.
I would imagine they would follow the same standards.
Okay.
I don't think they're different. And again, that's the 2061 or the NSES, or if you're on the cutting edge, the Next Generation Science Standards, which we are promised are coming out in spring. But we've heard promises before.
Year.
Yeah, it's true. They didn't specify the year. We thought it was 2 years ago, but they are really taking their time. And now when I look back at what they're doing, the reason why it's taking so long is because they are meticulously linking each of the science standards to the matching math and language arts standards. So when this thing comes out, we will be ready to rock and roll in terms of getting it into classrooms through the math door, through the language arts door, or actually if there's an open science door, we can stroll right in with them. So they'll be pretty cool once they're finished. And I know it goes to any kind of learning, so I'm sure adapting it to online learning, if that answers the question, I would imagine that would be what they'd use.
Yeah, I think so too. I think the standards probably are the same, because I'm thinking of just MoonMappers activity. You have observation, and that would be a standard, and they have to use their observation skills in order to and classification and so on, and those are all standards that are being addressed with online education.
Okay, cool. Yeah, the only part that is online is the MoonMappers activity itself, and so that's something you can, if you students can do at home, they can do it at home, but you can also bring them into a computer lab and do it with them in a computer lab as well.
And I'm sure some of the other things, there might be YouTube videos of crater making of different sorts.
Yep. I just want to point out, thank you, Detlef, you're awesome. 8 p.m. Central is 2 a.m. Greenwich Mean Time. So, so 2 a.m. Greenwich Time is when we'll be doing this intro hangout again. And so if you missed this one, you can watch the recorded video or come back tonight. We'll be doing this one more time. Do any of you have any last thoughts? We do have an email address, educate@cosmoquest.org, if you have any questions. After the hangout, you can ask us questions that way, or tell us your experiences with piloting the materials. Do any of you have any closing remarks?
Just to embellish more on what you just said, this is a work in progress, and we're still making adaptations to make it the best that it can be. So as you go through all of the whole unit, that would be great. We would love to hear what you did, how it worked, how your students enjoyed it, what suggestions you have, or even if you can only do one day here and one day there, any of the input that you can give us, if you can send it to that email that Nicole gave you, that would be great, and it would help us improve it a lot. We'd also take suggestions for future ideas of things that you would like to see.
And we have an online, or actually through email, newsletter for educators, which will come out once a month. And if you would like to sign up for that, go ahead and include that in an email or get a hold of any of us online, Twitter, whatever, and we'll put you on the list to receive this monthly newsletter. And as we develop and continue to make units and make changes, we can keep you up to date through that and other CosmoQuest events of this nature as they come up. Nicole, is it true that this will be actually archived?
Yes, this.
So if there were people that couldn't watch this that you know of, other teachers, and you want to point them, I'm not sure when that URL will be available or how that gets.
It will be posted on the Astrosphere Vids YouTube channel.
You will be able to watch this again at your convenience.
Yeah, I think that's where we are archiving all of the things. Right now it's being posted on my channel, which is not that exciting, but Astrosphere videos, I can post that link around. That is where all of our archived hangouts go. It also goes on the CosmoQuest page. Up at the top there's a link that says Hangouts, and then there's archives for the different types of Hangouts. This will go under special events, and so yeah, you can share this video with people after the fact.
Great. So let us know what you think. We're really hoping to get some nice feedback from all of you guys out there. And let us know how you're using it, too. If you are a formal classroom teacher, if you are a scout leader, if you are a parent that's just trying this at home, if your student is in a classroom where they're kind of bored with science and they just want to do this as an enrichment activity, we'll be really interested to know how that works, too, for you. So,
great science fair project.
It can be used many different ways. So
Scout troop.
tell us what you're doing. Yes.
Right.
Yeah, absolutely.
Excellent. And someone's asking about the times for the next week. We have 2 sessions next week again as well, so if you can't make one time, hopefully you can make the other. Same times as this week. It's 10 a.m. Central and 8 p.m. Central. You can use timeanddate.com to translate that into whatever time zone, plus or minus daylight savings you may be at. That's the only website that keeps me keeps me honest when it comes to time zone conversions. So yeah, I think that's it.
Thank you.
I think so. Yeah,
Thanks very much for being with us.
Thank you for your comments. Thank you for your questions. Thank you for watching. And I hope to see you next week. If you are interested, please RSVP at our Eventbrite page. Thanks.
Okay, goodbye.
Goodbye.
Bye.